Next, we'll cover using resources from the software's built-in model library to construct environments. The software includes numerous models such as vegetation, transportation facilities, vehicles, and buildings. Users can insert and arrange individual elements or create them along a path. For example, I'll now draw a spline and name it for easier finding later. Firstly, modify the layer name, then rename the current entity. Now proceed with placement. Select the tree model. Click Insert Along Path. Choose Tree Species, and add 3 tree types here. Next, configure parameters. You can adjust insertion spacing, random spacing variation, model rotation around the z-axis, random rotation rate, and random size scaling. This creates a more natural and realistic appearance. Select the tree spline as the reference, then click Create. Click the layer again to edit it again. For example, adjust spacing and update. Next, I will introduce a technique for inserting large area models, such as for forest vegetation. Firstly, draw a polyline and rename the layer. Select tree species and reference line. Crucially, configure offset parameters. Set the offset value and random offset rate. The software will then offset the vegetation along both sides of the reference line. You can make further adjustments as needed. This achieves the effect of planting trees across a large contiguous area. To summarize the model creation methods: single insertion, insertion along the path, and insertion along the path and offset. Choose based on your specific scenario. For details or unsatisfactory areas, secondary adjustments and model updates are also supported. Beyond vegetation, you can add buildings as well. A wide variety of types of architectural resources in the model library are available. Select high-rise buildings for insertion first. You can rotate buildings to adjust orientation or move them to suitable locations. Other building types, such as commercial structures and industrial complexes, are also supported. This concludes the tutorial on setting up vegetation and building backdrops. Feel free to adapt these techniques to your specific needs during creation. Next, we'll cover creating traffic flow models and a long path movement. There are 2 methods for creating traffic flow. One incorporates lane changes and follows lane logic. This relies on the AI road alignment, which contains road design information for simulation. The other method is a long path movement, which uses simpler logic requiring only reference lines. I will establish the logical lanes and lane group network logic first. Here's a basic example. Firstly, create a layer and rename it. The road alignment was imported via AI Road, enabling traffic simulation capabilities. Start by creating the main route network and selecting the main route alignment. Configure parameters like lane type, width, and coverage logic. After setting these, click OK to complete the main route network logic. Next, configure the traffic generator. Open the SIM module, select the generator, and add it to the lane. Use default departure parameters here, adjust as needed. Each lane requires a separate creation. At this point, the main route network logic and traffic generator design are complete. Click the model to preview its effects. Simulation speed can be controlled in settings. Observe the traffic flow closely to notice the lane change behavior. This traffic simulation closely mimics real-world driving behavior due to its network logic. Of course, you can also create merge and diverge logic. The tutorial on complex road networks will not be covered in this quick start tutorial. The second traffic simulation method is moving along the path. Create a polyline or use existing road alignment as travel paths. In the model library, select vehicle models. You can also open boats, trains, etc. In this tutorial, I will use cars as an example. Check Move along the spline, then add a vehicle model type. Select a reference line. Configure the speed and offset values. Click Create. Click View Details to adjust parameters such as speed again. This achieves a simulation effect closer to reality. Moving along the path method lacks complex road network logic. With that, we've covered both methods for simulating traffic flow. The next function is the Label module. Labels are categorized into 4 types: tabs, text, lines, and surface. Let's start with the text label. Create a new layer and rename it for Labels. Select the text label and click on the model to insert the label. The background defaults to a solid color, but you can change it and configure parameters. Select a prepared background texture. Adjust the background transparency to reveal the blue texture underneath. The system supports configuring spacing between text and the background image in all directions. You can edit the text content for the label here, such as the interchange name. Labels can be configured to face the screen, meaning they remain oriented toward the viewer regardless of rotation. The display range ensures labels disappear beyond a certain distance, preventing overlapping and visual clutter. Similarly, we can add another label, adjust it to the desired position, and complete the label creation. The software also includes predefined labels for lines and surfaces. You can insert them as needed. The next module is the Material module. On the right side, you can see the material library within the software. The software comes with some built-in materials, such as grass, ground, concrete, etc. Now, let's replace the grass on the road. Please note, if the Replace Same Type of Material option is checked, the system will replace all the model's material with the new one. The software also supports material modification. When modifying, similarly, confirm whether to check the Replace Same Type of Material option. Click the Material Suction tool and select the road surface. The system will open the Material Detail window. Adjust the effect to be darker. The software also supports the modification of other color parameters, like RGB values and transparency. The software includes numerous physical materials, such as water, glass, and metal, all with excellent rendering effects. Users can configure these settings independently. This episode, we introduce scene editing, traffic simulation, label creation, and material editing. The final episode will introduce the report editor.